Okay, time for another Banggood kit. Another clock. I do like the clocks, I have to admit, I've made loads of these things. So, let's see what this one's like. And as usual, it's going to be USB powered. Slightly different size jack than normal, actually. This is quite small. Most of them are a lot larger than that. But at any rate, 5 volt, USB, low power. That's the case, and there's the PCB. The case will be clear plastic acrylic. They usually are. There's a slightly different covering on that one there, so let's have a quick look at that. Let's cut this open, and it's not a particularly large clock, this one. As you can see from the LED, nothing too large there. So there we go. It's one of the clear plastic acrylic covers. So you can get the rest of this protective covering off. Go in the bin. There we go. And yeah, okay, so slightly different. Perhaps that was the end of the roll when it was putting the paper covering on the acrylic case. But there you go, so that's the case. Straightforward enough. Let's have a look at the PCB. Again, nothing too weird and wonderful. Bunch of resistors. Single chip, a couple of chips there, and that'll be the battery holder. That'll be the buzzer. Now the buzzers on these things are absolutely horrific to listen to, so I'm unlikely to install that because I'm not going to use them as an alarm clock, not by any stretch of the imagination. There you go, those are the chips and their respective holders. That's a switch for adjusting the time, date and all the rest of it. And the backup battery, which I would imagine is a CR2032 or something like that. No, it isn't. It's a, what is that? That's a CR1220. Perhaps that is the normal one, I can't remember now. But the fact that they provided a battery is good. Sometimes these kits don't. A bunch of resistors. Are they all the same value? No, I don't think. Or are they? No, I don't think so. So I'll have to check out what values they are. There's no instructions with this particular kit, so they might be online, so I might just go and check that out. Just make sure I put the resistors in the right place. And the rest of it, battery holder. There's the power jack. And a bunch of hardware. We have got a photoelectric cell, so that means that the I don't think this thing focuses. I'm actually using a GoPro here, so I'm not sure how well that's going to work. But yeah, so that means the display will dim when it gets dark, by virtue of that detecting the ambient light. There we go, there's the horrific buzzer, and they make a foul noise, so I won't even bother installing that. And we've got some ceramic capacitors in there. Are they ceramic? I think they are. What's that one? That is, well, it's got a 10 on it, so does that mean 10 picofarad? I don't know. And then a bunch of hardware. We've got a crystal. I don't know if it's got a value. It has got a value. I'll just have a quick read of that. 32.768. I can see written on that. Okay. That's the crystal. There's another switch in there, and a transistor, and the hardware for bolting the case together. So what I'm going to do now is I'm going to hunt down the instructions, assuming there are any, because what I'm not sure is which resistor goes where. I rather suspect that these two will go underneath the main chip at R5 and R1, but I could be wrong, and if I'm wrong I'm going to screw it up. So any road up, let's go and check that out, so I get the right components in the right places. I don't know what colour this particular one is. I'm hoping it's green. I think it might be green. And just looking at the number on the side, 5463BPG. I have no idea what that means, but I'm hoping that the G means it's green, but of course the B could mean it's blue. That's exciting. We'll find out when it's finished. Shouldn't take too long to put this one together. So let's stop the camera there, and I'll get back to you in a moment. Right, I went on to the Banggood web page for this kit, and as far as I can tell from a very grainy image of the circuit diagram, R10 and R9 are 10k, which makes me believe that all the other resistors are 1k, which kind of makes sense because I've got 3 10k resistors there, and I've got a whole bunch of 1k resistors. So I think that is likely to be the case. So with that in mind, and quite often they give you extra parts or spare parts if you like, so I'm going to need 2 10k resistors. I mean, obviously if it don't work then I know it's wrong, so we'll see. But let's bend these into position, dropping everything here. It's getting late and I'm tired and I've got to go to work tomorrow and all the rest of it, but I just fancied putting this particular kit together. So R9, splay those out to hold it in. Not the greatest way of doing it, but there you go, that's the way I normally do it. And R10, splay them out, pop them down, and then I need a bit of solder. I use pretty thin solder, certainly for these kits. They don't need much solder on them at all. Okay, and they do solder very neatly, these. I've never really had a problem with them at all, with any of the kits from Banggood. One or two been a bit there, but generally speaking they're pretty good. So I don't think my soldering iron's working, so let me sort that out. Okay, top tip, if you want your soldering iron to work, make sure it's plugged into the bloody mains. Right, okay, so let's solder these 2 10k resistors in. Let's say don't need a great deal of solder for these guys. Oops. Let's say doing this behind the camera is not the best idea in the world. There we go. Oops, a little bit more on that one I think. There we go. And let's just crop those leads. So it's surprising how many components are on this particular kit in terms of resistors. Putting these kits together is one thing, but understanding the electronics behind them is quite another. And I don't understand the electronics. I mean, I know in principle what a resistor does, what a capacitor does, how a photoelectric cell works, but could I explain to you what is going on in this particular circuit? No, I couldn't. I'm very, very much a hobbyist who just likes soldering these kits together. So I couldn't really decipher the mechanics of what's going on, but I can read a circuit diagram, and hopefully I've read this one. I say I can read a circuit diagram. I read one. Whether I read it correctly or not remains to be seen. Anyway, let's pull out some of these 1K resistors, and all the other resistor locations on this particular board should be, if I have read things correctly, they should all be 1K. And if they're all 1K, then we're good. If they're not, then I've got some hunting around to do and a lot of desoldering to do as well, to shift out the resistors into their respective places. I do make mistakes as I go along. The last video I did, I made a mistake, and it was the Christmas, not the last video, one before last, which was the Christmas tree, and I did get some resistors around the wrong way, and I thought as a result of that that the problem was the LEDs weren't good. They'd failed in some way, but it wasn't. The only thing that had failed was me. There was nothing wrong with the LEDs, so the kit was good. But the problem I do find is that the instructions for these kits are not good, if indeed you can find any instructions. Most of the time it's pretty obvious how they go, but the instructions, when they are supplied, can be a bit difficult to follow. Well, let's be honest, it's even worse when there aren't any instructions at all, rather like with this one. But as I say, I did find the circuit diagram, and let's just hope my ability to read it is accurate. So I'm populating all the remaining resistor locations with 1K resistors, of which there are many, and I had 3 10K resistors and 1 spare, and I've got a whole bunch of 1K resistors and 2 spare. So that kind of makes sense. I always keep the spares because if I get other kits, of which I am going to get other kits, and many of them, if there are any parts missing, there's a good possibility that I'll have a replacement with me. So, okay, right, you don't need to see me solder this lot up, so let's solder them up and I'll come back to you. Right, that's all the resistors installed, and I've made sure they're all flat against the PCB, so that's good. What's next? We have got, empty this lot out. This is where I start losing bits and pieces. Get everything out. Right, let's have a look at these capacitors and see what values they are. I think we're looking hopefully all at the same value, which is 10 puff, 10 picofarad. Let's have a look. Yep, and they're all 10s. Well, I don't know if that's focusing or not. Probably not. But there you go. They're all 10 puff. So we can install those at these locations. There's one there. There is one there. Can't see any others at the moment. I'm sure they're do you know, that might just be it, and I've got a couple of spares, which wouldn't surprise me, unless there's any locations on the back. Doesn't look like it, but there's certainly a couple and go in those 2 locations, so let's install them. I'll try and get them as close to the board as I possibly can without physically cracking the casing of the capacitor. Oh, no, that's in the wrong location. I was about to put it where the crystal goes. And that would not have been clever. In fact, I'll tell you what I am going to do. I'm going to, I'll put this one in for the moment, and I'm going to put the crystal in before I put that second one in, because it's going to be pretty difficult to solder, and if I don't do it in that sequence. So that's that capacitor. Trim it off. And I think I'll get the now where's that crystal? Bits everywhere. I haven't sorted myself out, have I? There it is. Okay, and I think the crystal needs to be soldered down to that pad there. So that's where the crystal legs will be soldered, and I need to make sure it goes down to that pad and solder it there as well. So I'm not sure, keep on going off camera, apologies for that. If I can get that down reasonably close to the board and then fold it over and have enough space to get some solder on the can of the crystal and that pad. So what I'm going to do, I'm just going to start off, put a blob of solder on one of the legs, like that, and then force it down to the board. So that means that the leg, the can will be nice and close to the board for soldering. I might try and do that again. I think that's a bit better. Yep. So let's solder the other leg. It's not particularly straight, I have to admit, but oops. Almost chucked the iron across the table, which wouldn't have been much fun. Crop those legs, and then yep, and can is just about straight enough to solder to that tab. So let's see if we can do that. And I think that's it. That's the end of the can soldered to that pad. Now I can do the other capacitor, which was what I was concerned about. I wouldn't have been able to solder it too easily, or solder the crystal in that way too easily with that capacitor in the way. So now it's done, I can put the capacitor in. Like that. So you can see that this is, you know, a pretty straightforward little kit. Nothing weird and wonderful here. We've got, what are we left with? RM, I would imagine, your RM and GM. Now often these kits display the temperature, and for that it needs a thermistor, but I don't see a thermistor. I missed a resistor there, look, R7. Well, what would you credit it? Let's hopefully that's another 1K as well. Pop that in there like that. So one of those locations is the photoelectric cell, but I don't see a thermistor in the kit. If it's supposed to have one, they've not supplied it. Anyway, we'll press on for now. So what shall we do next? I think what we shall do next is, well, what I could do is start populating the sockets for the ICs, and you can see that they've got little notches in them. I'm losing my voice here. They've got little notches in them, one there and one there, and that will correspond with the notches on the screen printing for the location of the chips. So what I shall do is I'll pop them in there and then solder them at the back. So there's quite a few pins to solder, obviously. So what I shall do is I shall go away and do that right now, and I'll get back to you once they're all soldered up. Okay, so that's the two IC sockets installed and soldered up. Next thing I think will be the transistor. 3 legs, base, emitter and collector, and you'll see that one side of the transistor is flat, and you can see on the circuit or the screen printing where it goes, there's a flat side. So quite simply, flat to flat, something like that. So we'll again get that down as far as we dare without destroying it, and you can see the legs are splayed out quite neatly on their own there. So that's installed relatively easily. So a blob of solder on each of those, and we shall be good to go with the one and only transistor. Well, other than the transistors and the chips, of course. And there we go, so that's that. Let's crop those pins. And we're getting pretty close to where we're going to be installing the LEDs. I haven't plugged the chips in yet, of course, so I'll do that in a minute. I think the next thing we'll do is the battery holder, and you can see that it's got a plus and a minus sign on where the battery holder goes, and with lithium cells, all these little button cells, the base of the cell, which will touch this spring-loaded piece, is negative, and the top and edge of the cell is positive. So on that, so this negative, this spring will be the negative contact, and that meets up with that tab. So the holder will go in like that. You can see that, and there'll be a fair bit of actually those pins. Now, interestingly enough, on the bottom of the holder are 2 plastic pins, and the idea would be that the PCB would have corresponding holes for those pins to go in, but there are no holes. The other thing I've noticed is that the length of the tabs on the battery holder are going to cover the 2 contacts that it needs to solder to, so that might be an issue. Anyway, I think the first thing to do is we need to cut off those plastic pins, because we're simply not going to need them. Let's win, and that's the t'other one. So now that will fit neatly onto the board like that. But you can see the tabs of the battery holder completely cover those pins, which is going to make it a pig to solder. So what I'm going to do is I'm just going to crop them a little bit, so I can see at least some of the tinning. Actually, probably all I need to do, thinking about it, it's probably a bit of a stupid idea doing that way, actually. Probably the best thing to do would be just to tin the contacts like that and like that, and then losing my voice here. Then all I need to do is just hopefully heat that up a bit, and some of the solder will splash across the top of the contact there, and likewise, I haven't got that very straight, have I? Let me add a little bit more solder this side as I press down. Like that, and let's just give that a little bit more solder this side as well. Probably doesn't need it, but at least I know it's making a good contact. And there we go. And that the battery, of course, is for backup. So when the main power is unplugged, the battery still keeps the system clock going, so when you plug it back in, it will still show the right time. Now the buzzer, as I mentioned earlier, I hate these with every fibre of my body. They sound hideous, so I'm not going to install that. So that's one thing that we would not going to need to do. But if you do want to install it, you'll see that there's a plus symbol there, and on the actual component there is a sticker with the plus symbol, so that would be the positive pin there, and that would be the negative. So if you were to install it, it would go in that way like that, but we're not going to do that. So next thing to do is install the switches, I think. Doesn't matter which switch goes in which hill, and they go in like that. Excuse me. There's one, and then there's the other one. Come on. There we go. And obviously they're used for setting the clock. So let's solder those into place. Making a bit of a pig's ear of this, nevertheless it's gone in, as has that one. And that's the switches. So let's have a quick nose at that close to me short-sighted eyes. Yep, they're all in. So that's the switches. A couple of push to make switches, and the next thing I need to do is I just need to sort out where this photoelectric cell. Wait a minute, I've got a little component here. I didn't notice that. That was stuck to the polystyrene or whatever the chips are plugged into. So that, I guess, is that a thermistor? I'm just going to double check the correct location by looking at the photographs on the website of a completed kit and make sure I've got them in the right place. Okay, right, well, I've sorted that out. So the photoelectric cell will go in this side, and the thermistor, which is what I think this is, will go in that one. And both of them will actually poke out the top of the case. There's cutouts in the case for them, so what I'm going to do is I'm going to leave them about that long, I think will do it. And let's just do that wasn't good. Right, so yeah, so let me just put a blob of solder on one pin. I'm sure there's a better way of doing this than the cack-handed way I'm doing it. And neither of these components are polarity sensitive, so I'm burning myself at the same time. That's not good. There we go. It's going to be something like that. The trouble is I should have really offered the case up to it to really be sure what the positioning should be. I think that'll just about do it. We'll go with that. And then solder the other pin. I think my camera is deciding to go walkies. So let's try and set that up a bit better for you. That's all professional stuff, isn't it? There we go. Right. Solder that other leg. Like that. That's those two off. And then similar with the what I'm calling a thermistor, which should detect temperature incredibly inaccurately, although you can usually calibrate them, but I never bother because I'm not really that fussed. But you might be, in which case that's fine. So hopefully, again, let's just do a blob of solder on one pin and then reposition it. Like that. I think that will just about crack it. And hopefully those will go through or match up with the holes in the case, because they can't be inside the case. Well, particularly the thermistor can't be, because it will be detecting the temperature inside the case when what it needs to do is to detect room temperature. I don't think it really matters for the electric cell actually, because the photoelectric cell, because the case is clear, so light will pass through into it anyway, so that doesn't matter. So that's kind of how it should look, like that. Oops, camera's on the roll again. The next thing to do, I think, is before we install the chips, is to install the power jack, that guy there, which plugs in like that. So what I'm going to do, again, just solder one of the pins for now. I've got to do that top one there. Okay. And actually that's pretty flat. Yep, I think that's okay. And the other two pins, and a bit more solder on that one, and that's the power jack installed. Just check the soldering. Yep, crap as always. So not very straight, that one. Never mind. Okay, So you get the idea anyway. So the next thing to do is to install the two chips. So I think I'll do the trickiest one first. You'll see that the pins and these things are splayed out a little bit. So the thing to do is just to put them on the table there and give them a little bend to straighten them out a bit. And that will make it a lot easier to install into the holder. You've got to watch these pins because quite often the pins can get bent and buckled about during transit, bearing in mind they're coming all the way over from China, so they get some fairly harsh treatment. So let's see if I can get these in there. I might have to do this off camera. Right, I'll get in there. I probably need to bend the pins a bit more actually, if truth be told. Okay, so I've got them sort of lined up, and then you just pop them in like that, and that one is installed. And again, you've got the notch on the chip itself which matches with the notch on the PCB and the socket, and similar process for the smaller chip. Give the legs a little bend, and take note of the notch to get your orientation right, and then cram it in there. Again, let's go off camera. This one is proving to be a little awkward. Well, there we go. There she is, so pop her in. I think, yes, Houston, we have a problem. I have managed, with too much brute force, to bend one of the pins underneath the chip. So that's not going to work, is it? So, there you go. There. Let me get the needle nose pliers out. I've got the wrong glasses on, that doesn't help much. That's normal, I can't see a damn thing. Okay, let's straighten out these pins once more. God knows if these are static sensitive, then I've completely blown them. I don't think they are. Right. Let's try that one more time. There we go. God, it's like the Keystone Cops, isn't it? Okay, so I think we have populated the entire main board now. As I say, I'm not going to put the buzzer in because I hate them, and I won't put the battery in just yet. No need for that. So the final thing is the LED. Now, looking at the photographs, the writing is at the bottom and the top is clear. So on that basis, it will go, it will go like this. Let's have a look at those pins. Are they bent? Yes, they are. I'm going to have to take my glasses off or go and change them, I think. Just have a quick look at the pins. Yeah, they're a bit bent about, which is not good. Okay, so let's populate one side, and then the other side. Just trying to get the pins lined up with their respective holes. Just proving more difficult than it should be. Sorry, I think I'm off camera again. Right, give me a moment. Well, I made that more difficult than it should have been. Right, there we go. So that's the LED or the display plugged in. So what I need to do is find the right glasses, and I seem to have lost them. Right, here we go. Right, that's better. I can see what I'm doing now. So we just need to solder each of the pins of the LED. So let's grab a bit more solder. Okay, and move this out a little bit so I can get to it, and we should go along. Actually, before I solder anymore, make sure that's nice and flat against the PCB, which it looks to be. Okay. Let's start from this end. And that one. And this side. Ooh. And that's that. So I'll crop those pins off a little bit later. But assuming I haven't completely and utterly cocked this up, and I'll take the protective cover off the LED. But assuming all is well, the next thing to do will be to power it up and test it. So I won't bother with the battery just yet. Okay, so let me go and get my power supply, and we'll give it a go. Okay, so I've got my USB power supply, plugged in the cable that came with the kit, and I'm going to plug that into, there it is, into there, and hopefully it'll work. Let's do it the other way around. God, the suspense is killing me. Right, here we go. Boom. Hey. Let's switch the lights off. Oops, and the camera has just fallen down. And good news, it's a green display, which is what I wanted. So there we have it. And apparently, now we do have. Ooh, that doesn't look good. It seems to have died. Ooh, let me have a look at that and see if we can bring it back to life. Right, well, you might recall a little bit earlier, I'll just get this camera sorted, that I missed a resistor. And the resistor I missed was that one there. If you seem to recall, when I was putting all the 1K resistors in, these two are 10K, and I had a spare 10K. I had a couple of spare 1Ks. But of course, I went and put a 10K in there instead of a 1K, because I'm an idiot. At any rate, he's now got a 1K in there, and let's see how she fares. Plug her in. And I think, let's just bring the lights down, I think that is a fully functioning clock. Now, seems to flash when you press buttons, which I would suspect. Ooh, it's gone again. Look at that. I wonder why that is. Oh, it's working again. There's something a little bit odd going on, I have to admit. So, there you go. It's a bit flaky, so I might have some... I've also got some iffy joints in there. Let me go back and check my soldering. Well, I've had a play around with it and I've checked all the soldering. It seems to be working with the time. You can see I've got it set there. Let me... Yeah, let's put the lighting off. That's a bit better. So you can see there the time, and that seems to be working okay. The photoelectric cell isn't working. It's not dimming it, although it did start to at one point. You can see there it's a bit flickery, so I'm wondering if I've got some issues on the board somewhere. But this is interesting. If I go into set mode, so we've got the minutes flashing there. So press it again, the hours are flashing, fine, and it adjusted okay with the other button. Press it again. Now what's that all about? Let's try and just bring a bit more light up. No, that's not going to work. That's better. And you can see that the second digit is going from 0 to 8, and yeah, it's clearly not happy. So let's press the button again. It's trying to change that. Let's see what that goes up to. 10, 11, 12, 13, 14. So that's obviously going to be 24 hours. Yeah. So that's obviously, perhaps that's the alarm, I don't know. Now we've got zeros. And then it goes to 11:11 if I press the set button. Like this, and there's something really not right with this. And you press it a few times, it comes back to the time again. So, and now that you see the temperature's shot up there for some reason. I don't know. I don't know if I've screwed up somewhere or I've damaged the chips or whatever. But I think this is a software problem. I don't think the software on the chip is functioning correctly. And also if you look at the flashing dots, which are supposed to represent seconds, well, that's faster than a second. And oh look, you can see some flickering going on there, so that could be a hardware problem. I don't know, but it's not functioning correctly, that's for sure, which is a shame. So I think what I might do is I might pop those chips off, because I did struggle installing them, and see if that is causing some problems. But yeah, I don't know. It's all a bit weird. Let's bring the light back on again, and I'll unplug it. So what I'm going to do is I'm going to rip those chips off and see if there's anything underneath that might be causing a problem, or I have a fault here, or I've got some resistors wrong still. I don't know, but I don't think so. But my suspicion is software. Let's have a dig around and see what I come up with. Right, well, I've had another go at it, and it's still giving stupid readings, so I don't know. I've reflowed a lot of the components just in case. Everything is in its proper place. Whether or not there was damage caused by the fact that I had no instructions and I went and put a resistor in the wrong place, I don't know. But yeah, I don't quite know what's going on. What I think I will do is I'll just run it for a while, and I'll put the case on it so you can see what it's like with the case on. And it might be that I'm just unlucky and I've got one that is perhaps got duff software on the chip or something like that. I don't know. Let's put the case on. Right, well, that's the case installed. Yeah, nice enough case, the typical acrylic cases that you get with these kits, so no problems there. The hole for the thermistor was too small, and I couldn't be bothered to drill it out, so I just bent the thermistor back, as you might be able to see there, so that's a bit silly. What else? You can see where the photoelectric cell protrudes, but that doesn't work. The Deming isn't working at all. That's not functioning. It does seem to be telling the time correctly. So far so good on that, so I think I shall leave it running for a while. I'll put the backup battery in there at any rate to see if it carries on keeping the time. That temperature's rubbish. Okay, what else? There were no instructions, so obviously there was guesswork on where the resistors went. All the other components are fairly straightforward. The LED, again, judging as to whether or not the orientation is correct, I happen to know that the shape of these particular LEDs, but if you were not familiar with them, then you could quite easily solder that in upside down, again because there's no instructions. So yeah, it's okay, but it's clearly not functioning correctly. Might be my fault. I actually don't think it is. I think there's a software problem there, and yeah, I did put a resistor in the wrong hole, but I suppose that's the danger if you don't supply instructions. So there you go. So that's that one. I'm not going to spend any more time on it. Job done as far as I'm concerned, and we'll move on to the next one. So there it is. Can't particularly recommend this one for the reasons I've already mentioned, which is a shame because overall it's not too bad. Another thing is it's got a bit of a weird design. You can see that the LED display is right at the bottom against the base of the case, and there's got this big gap. You know, it's just not designed very well. Oh well, that's my view. Anyway, hope you enjoyed the vid, and we'll catch you on the next one. Cheers.